Excellent. So recording started. So I wanted to recap of what we've been talking the last couple of classes. We talked about EC2 instances, of course, after talking about cloud computing, AWS, all of that. So especially when it comes to storage attached to an EC2 instance, we call it block store, right? So you can attach block storage to an EC2 instance, like you're attaching a hard disk to your compute. So there are two types of block storages. One is instant store. So briefly we talked about it. Instant store is something that is ephemeral. It's a temporary. It's a physically attached to host computer. It's a physically attached. It's a temporary block store. And when you stop your instance or you reboot your instance, all the data that is stored on that temporary storage is gone. So you may be wondering, why do you use this? Well, we use this for in-memory databases, things like in-memory databases, any in-memory caching, etc. That's what we use instant store for. Okay. So that's instant store, and the second one is permanent, which is EBS, elastic block store. This is where we played. Sorry. So elastic block store, EBS volumes. So we played with EBS volumes yesterday quite a bit. So these are not physically attached to host computer, but these are separately attached. Okay. So all the virtual machines, let's say you have one physical server that has 10 virtual servers, right? So in the case of instant store, that's directly attached to the physical host computer, but in the case of EBS, it's not. It's separately attached, and multiple host computers can share it. But EBS, it can be detached from your EC2 instance. Yesterday we saw how to create a new EBS volume and attach to an EC2 instance. And then later we detached it. We wrote the files, we detached it, unmounted our directories from it, detached it, keep it aside, and then reattach to some other EC2 instance. But EBS, you will not lose the data because it's permanently written onto the disk. So it will survive your reboots. So there is a third type. It's not really a block store. Yeah, it's a different kind of storage mechanism. We'll talk about it later. It's called elastic file storage, EFS. So with the case of EFS, tens of thousands of EC2 instances will be able to write and read concurrently. This is like your multiple Unix machines having a shared file system, like an NFS mount. You guys may be familiar in your workplaces that there is an NFS mount attached to multiple Unix computers or Linux machines. You guys know that. So that EFS is, it actually uses NFS protocol only. I'll talk a little bit more in depth later on how to mount it, unmount, etc. Okay, it's a more scalable, more elastic approach actually. So here, with the case of EBS, so when you attach an EBS volume, you're going to say that, hey, I need 50 gig of EBS volume. So you'll be charged for 50 gig whether you use it or not. I want you to understand that. And then EBS volumes can be attached to only one EC2 instance at a time. So these are about storages and storage volumes. And briefly, let's talk about the instance types, EC2 instance types. So we have a different types of EC2 instances there. So we have been using the T2 micro, T2 nano. These are all general purpose, T1, T2, T3. You have your M4, M5, M6 also. See, some of them will come with the more RAM, some of them will come with a minimum of X number of CPUs, etc. So these are general purpose, these types. You don't need to remember the types at all, but just wanted to give you a high level overview, right? This is the perfect balance of compute, memory, and networking resources, these types. And you have your compute optimized, your C4 and C5. So there you can go with the C4 medium, C4 large, C4 extra large. Okay. So C4 extra large comes with 16 core CPUs, or even the 32 core CPUs. It costs you a fortune. Okay, they're probably needed for high computing stuff. Okay, maybe for your analytics engine, artificial intelligence kind of loads. Okay, if you're running a nightly batch on video processing, okay, if you want to run it for a couple of hours, that's when you'll use this compute optimized. And you have your memory optimized. These come with the large RAMs, R4, R5, such. And then you have a GPU optimized. This for complex calculations and GPU accelerated computing, GPU centric. You have your G3, G4, P2, P3, F1, like that. And you have your storage optimized. These are actually sequential read write and local storage. These are good for databases, high performance databases, etc. Yeah. So if you just understand it, you will know, hey, I need a EC2 instance. In my previous life, we were using a software called AppG. AppG is an API gateway, and we installed it in-house in an EC2 instance. At that time, we were comparing, hey, what will be the right EC2 instance type? And then AppG comes with its database. It writes everything to Cassandra databases. And we had to kind of create a Cassandra ring across 2 different regions. So at the time, we were thinking about, okay, what will be the right side? What will be the right instance type? Okay. So Cassandra database, it has to be storage optimized. You have your AppG edge servers, let's say. Okay, these are highly compute optimized. Then go for C4 large or C4X large, something like that. Okay, so you don't need to memorize any of it. Just wanted to give you a high level overview from the exam perspective. You do not need to memorize. Understand that. Okay, so let's talk briefly about this EC2 pricing options. There are 3 pricing options in EC2. The first one is on demand. So if you use your EC2 instance for an hour, you'll be charged for an hour. If you use it for 4.5 minutes, you'll be charged for 5 minutes. It's a 60-second billing in some EC2 cases. Okay, actually EC2 goes with the 60-second billing, but there are some resources where it goes per second billing. It's not per second, actually sub-second billing. Even for 500 milliseconds, they charge you only 500 milliseconds. Okay, so on demand is it's purely just that. Okay, these are good when you don't know, if you don't know what your needs are. You just pay for what you use. The second one is, actually, let me swap this one. Number 2 must be the reserved instances. Let's talk about the reserved instances. If you know your typical load profile, and you are a decent size organization, and you know your typical load profile, and you would need about 80 EC2 instances for the next 3 years, let's say. So in that case, what you can do is you can go with the reserved instances. Reserved instances, you are signing the contract. You're signing the contract with AWS that I need these many EC2 instances for 3 years, and you will get a lot of discount in that. Almost about 30 to 40% discount with the reserved instances. Yeah, you'll be paying less because because AWS is, Amazon is assured that you'll be paying for the next 3 years. And actually, by paying upfront for the entire 3 years, you'll be even paying less. For something like a T2 Nano, for 3 years, it costs about $150 if you pay upfront. So the 3 years, that instance is yours. You can do anything. You can run anything on it. 3 years, $150, about $150. You can use that AWS price calculator. Okay, so that's about the reserved instances. And there is a third option called spot instances. This is more interesting. So spot instances, see, in the reserved instances, you are committing for 1 year, or you're committing for 3 years, and your discounts are based on how long you are committing to AWS. So here, you are not committing to AWS at all. In the on-demand case, you are not committing. Hey, if I use it for 2 hours, charge me just for two hours. So in the case of spot instances, it's completely reverse. AWS will not commit to you. So in the case of on-demand, you will not be committing to AWS. But in the case of spot instances, AWS will not commit to you. Meaning, this is like a bidding in eBay. So let's say I need T2 or C4 large. Okay, let's say it's a typical on-demand price is $1 per hour. So, and you can do a bidding. You can bid on it. You can say that, when it comes down to 50 cents per hour, I need it. So mine is a batch job. It can run anytime. I'm running some genome calculations. I'm running some complex calculations. Okay. And I know I need it for 4 hours. Okay. But it doesn't have to be now. There's no time specific. Okay. I can bid for that. So when price drops below 50 cents per hour, okay, let's say the price has come down, due to bidding, the price has come down to, let's say, 20 cents per hour. Amazon will charge you 20 cents per hour, even though you bid for 50 cents per hour. Okay, it's running at $1 per hour for on demand. Because of the bidding, the price fluctuated, because there is a lot of inventory left. Nobody is using it. So what would Amazon do? Amazon can let them use it for a cheaper price. But as soon as the price goes above your 50 cents per minute, they will take out the instance. So they will not commit. So if you get that, if you are in that price range for 30 minutes, you will get that EC2 instance for 30 minutes. If you are in that price range in the middle of the night, let's say 1 a.m. until 4 a.m., okay, a lot of EC2 instances are empty. And then at that time, maybe you get it for 3 hours. Okay, run your job for 3 hours at that time. So you're saving a lot of money there. That is about spot instances. You can save enormous amount of money with spot instances if you are really flexible. But that's not for every single use case. If you have some job that needs to be run, and it doesn't have to be run in a specific, there's no specific schedule out there, then you can use your spot instances and you can save up to 80%. But Amazon is not committing you. So Amazon could take away your EC2 instance anytime, right? Because once the price goes up, it will take away. So there is a concept of, when you're using spot instances, you can go for there is a concept called spot block. When I need this spot instance, when you assign me a spot EC2 instance in the bidding, okay, I need this for 4 hours, because my job is going to run for 3.5 hours, so I need it for 4 hours. You can request that. And that is called spot block. You'll be paying a little bit more, but essentially spot block, Amazon will not take away as soon as the price goes up. You are committed, Amazon is committing for that specific number of hours. Does that make sense? This is the most economical one, but not for all the use cases. Absolutely not. And this is what you're using on demand right now. And the reserved instances for the companies that know they would need this is for the companies that know their sort of capacity. If they know that they will be needing 10 EC2 instances for the next 3 years, you better sign a deal with AWS, and you will get almost 30 to 40% discount. Make sense, guys? That's about pricing options. Anything before I move on to some other topic? Any questions on that?
So these are like it's a selection on demand, but like all online, right? Like there is no, as you said, like contract signing and it all, right?
For reserved instances, you'll be signing the contract. Essentially, you'll be paying it. Yeah, it's signing the contract, meaning you'll be paying it. You'll be within an organization. Yeah, you'll be signing the contract, and or if you want to pay ahead of time for all 3 years, then pretty much you give your credit card details and you're all set for 3 years. Make sense?
Hey Venkat,
yes.
This is Radha. So I'm going back to previous slide, like instance types.
Mm-hmm.
So all these types, like either general purpose or compute
mm-hmm.
optimized or everything. So the naming is completely like out of the way, like A1, T1, T2,
yeah.
C4. Is there any specific logic to that, or just it is random?
Actually, that's an excellent question. If you really look at the R here, R stands for RAM. Okay, yeah. C for compute, G for GPU.
Mm-hmm.
It's and these are general purpose. There are some mnemonics online out there, but why did they call it T rather than something else? Okay.
Yeah.
For some of them, this is again R for RAM is our understanding. AWS did not really specify it anywhere.
Yeah, they just picked up some alphabet.
Yeah. It's like your alpha, beta, gamma type situation.
Mm-hmm. Mm-hmm. And even the numbers doesn't make any sense, right? It is just like that they are random numbers.
R4, C4, C5. Yeah, that's actually, if you click on EC2
mm-hmm.
and go to the instance types here. See here, instance types. So these are all the instance types. So let's say C4, see this one, C4 large, right? C4 mm-hmm. large is coming with 2 virtual CPUs. Okay, and it's coming with 3 gig RAM.
Mm-hmm.
But let's go for C4X large. It's coming with 4 CPUs and almost 8 gig RAM. And then C4XX large is coming with 8 CPUs. Yeah. So what does 4 stand for really? It's not documented anywhere. Okay. So yeah, this is your network performance, and this is your RAM, and this is number of CPUs. Actually, you go with that. Let's see this one, X132 extra large. It's coming with 128 vCPUs, virtual CPUs. You just click on it and then look at the price anywhere. So these are all the valid cores, it seems. So it comes with even the 64 cores. But look at it. Pricing, $13 per hour. On demand Linux pricing is $13 per hour. Windows is $19 per hour. If you want to go with this one.
So Windows is higher?
Yeah, obviously, any day Windows is higher, right? Because you'll be paying the licensing to Microsoft install. Linux is free, right? That's why. So 96. So you can go with that. Just C5 24x large. What's your $4 per hour? Oh no, I mean it feels okay because you're getting how many CPUs is that? 96 CPUs, 96 virtual CPUs with that. Okay, go ahead. Sorry.
Yeah, maybe 100 is the limit, and then anything above 100 is something cost more. And
Yeah. Because these are 100 core CPU. You know what it means? That's like a beast, right? Okay, so let me switch gears from EC2. We'll have some fun. You'll understand why I'm doing this one. Okay, I wanted to spend a minute here to talk about a service, one of the oldest services out there from AWS called SNS, Simple Notification Service. So Simple Notification Service is, as the name says, it's a notification service. It's used to notify the events between the applications. So it's in a event-driven architecture or serverless technologies. So these applications are decoupled. Application A wants to talk to application B, but my application A's availability depends on application B availability. Because if B is down, then I'm making a REST call. Then if B is down, then my A will be down too. Because that is down, I depend on B. So in that case, you want to decouple the architecture. How do you do that? Well, you can put, you can go with the event-driven architecture. So essentially what happens is, application A posts it just event out saying that, hey, something happened here. You know, recently I was watching a video about event-driven architecture that's explained by Martin Fowler, and he was taking this classic example. It's an insurance company example. So there's the insurance, multiple departments out there, and then a customer's address has been changed. Oh, there is a CRM system out there, customer management system out there. So they know that address has been changed. As soon as the address has been changed, it just evented out, meaning it just sends a notification to somewhere saying that, hey, this customer's address has been changed, and all the systems will be subscribed to that events, and then do whatever they want to do it. Let's say system A, let's say their insurance pricing application, it will be subscribed to that. As soon as address is changed, they will recalculate, reevaluate the new insurance premium, and then send out an email saying that your insurance has been changed, increased or decreased, whatever the one is, right? And then let's say there is let's say there is a plastic card service. They will get subscribed to that, and they will ship out, they will manufacture the plastic, the actual identity cards, and then send out to home with the new address. So all these systems, when an event is notified, all the systems are listening to that, and then they're acting on it. So that's the perfect decouple between the systems, right? So you can use this simple notification service, Amazon's simple notification service. Essentially, there are two parties here, publishers and subscribers. So this publisher, this application A, will post a message into something called topic. There is an SNS topic. Okay, this is your typical pub sub model, right? In your messaging architectures. So there is a concept of topic here, and this topic, you can add multiple subscribers to it. A piece of code that's listening to this events on this particular topic and act on it. It can be a Lambda function. It's a simple function that's deployed out there. Or a queue service. It's called SQS, simple queue service, or another HTTP event. It will call your REST endpoints, or it can push an email notification, or it can send an SMS message. It's just a push mechanism here. It's not a polling though. It's a push mechanism. This SNS topic will push to these subscribers. All these subscribers are subscribed to this particular topic. And this SNS topic is part of this SNS, simple notification service ecosystem. It's a common messaging architecture, and Amazon has a service for that. It's called simple notification service. There's nothing more to it. So let's go ahead and create this new topic and create a new email subscriber. And then later on, we'll be publishing it. I'll show you why I'm explaining this, a simple service, right? So let's go ahead and go to services and then type SNS or simple notification service. Go to simple notification service. Yeah, this is what a similar diagram I picked up. So this is your dashboard. You don't have any topics out there. So at this point, so let's go ahead and create a topic, a simple topic. This one, let's say, my goal here is that, I'll tell you my use case, then you'll understand. My EC2 instances, I have a couple of EC2 instances here, guys, okay? My EC2 instances, when any of these EC2 instances CPU goes above 80%, I want to get notified. That is my use case. I want my on-call team to be notified, to be precise. And let's say there are 20 different email addresses that are subscribed to this. And also there is a function that needs to be called, and that's going to do something else. Make sense? So in this simple example, I'm going to have a simple subscriber, a email-based subscription to this one. So let's go ahead and create a topic. So what it does is, I'll call this EC2 high CPU alert. Okay, this is the notification. This is a topic. All the high CPU alerts for my EC2 instances, they will write to this particular topic. Yeah. And then encryption, access policy, I don't need any of this. Just let's go ahead and create a topic. And then at this point, this particular topic doesn't have any subscribers. So let's go ahead and add a subscriber here. So select protocol, you can do a HTTP, HTTPS, you can use your lambdas, and mine is a simple email. Email is Venkat next step the training, and then subscription. I don't need anything. I don't need any DLQs. Okay. So this is I'm subscribed and it's waiting for pending confirmation. So I'll have to check my email. I got an email saying you have chosen to subscribe to this particular topic, EC2 high CPU alert. Let's go ahead and confirm it. Very good. It's confirmed. Now let's go ahead and refresh this guy. Very good. It's confirmed. Now let's take a look at this particular topic, EC2 high CPU alert. That's and all my on-call people will be subscribed to this particular topic here. Okay. Or let's say there is a group email. Yeah. On-call email. That can be the subscriber here. Essentially, I'm the only one here. So this is good, guys. Okay. And yeah, it's that simple. SNS. Yeah. So now let's use this one. Let's use this one. Now we talked about simple notification service. I'll talk about something else called CloudWatch. So there is an addition, there is another AWS service called CloudWatch. CloudWatch is nothing but AWS's monitoring service. What exactly is a monitoring service? Well, you have your EC2 instances. I mean, it's not specific to EC2 instances. Later on, we'll talk about application load balancer, etc. But essentially, EC2 instances, let's take that as an example. You can have CloudWatch continuously monitor it. So let's say CPU spikes, it will monitor. Disk spikes, it will monitor. Anything in between, network spikes, it will monitor. So you can have a monitor. Essentially, CloudWatch is all about monitoring. So if CPU goes above 80%, then I want to send an email to that particular topic, and my email is subscribed to that. I want to get an email. I want to get the notification. Of course, later on, I'm going to show you that when CPU goes above 80%, take some action on it. Meaning, terminate the EC2 instance and create a brand new EC2 instance and add it to the pool. We will be doing that later, but let's take baby steps. By the way, later on, when we talk about these Lambda functions and all, we will be looking at the logs, and you will go to CloudWatch to look at the logs. All the logs are written also by default into CloudWatch. So CloudWatch is nothing but a monitoring service and your logs collector. Yeah. So what we will do is, let's go to CloudWatch. I wanted to show you how CloudWatch looks like. This is how the CloudWatch looks like. And so you can watch your auto-scaling groups, EC2, EFS, EBS. Okay, all of this you can have in your dashboard, or you can create a brand new dashboard. Okay, let's go to EC2. I don't have any EC2 instances right now. Okay, so you can look at all the, you can create your own dashboards. Currently, I do not have any EC2 instances. Okay, and you'll be able to create the alarms. You can click on create alarm, CloudWatch alarms. This is a CloudWatch alarm. That CloudWatch alarm is the one that is going to push a notification into my topic so that I will get the email. Make sense? So select metric. Let's take a look at, let's go ahead and create alarm. Select metric. So what metric you want to do it? Well, I want to, because I'm talking about EC2 health check. So I want to look at EC2. Okay, EC2 by what? CPU. So let's search for CPU. EC2 per instance metrics, EC2 across all the instances. Yes, I want per instance metrics. So let's go. And then see this one, CPU utilization. Take a look at this guy here. So I know this is an instance ID. So this instance ID does not exist. So what we will do is, let's go ahead and create an EC2 instance and come back, because I currently do not have any EC2 instances. So let's do that. So we will create an EC2 instance and then create an alarm. The alarm, what it does is, if CPU utilization goes above 80%, put a message into the topic. Our topic is CPU, high CPU alert topic, which will push an email notification to me. So let's go ahead and create an EC2 instance. Yeah, and we already have an AMI, right? So let's go to AMI. So actions, actually, go ahead and I selected my AMI and then launch. This is going to be my web server 1. Security group, use an existing security group, web servers, review, launch, prepare. Piece of cake. It's bringing up. Oops, actually, as part of your creation, maybe let's let me show you one more. Let's go ahead and kick off one more instance here. I wanted to show you something. Yeah, see here in the configure instance details here, monitoring. Take a look at this monitoring. Enable CloudWatch detailed monitoring. So read this one. By default, your EC2 will be monitored every 5 minutes. Okay, I don't want to wait for 5 minutes. My needs are very specific. So I want a detailed monitoring. Detailed monitoring will give you every 1 minute. Okay. You can have, see this one? You can enable detailed monitoring where data is available in 1 minute periods. By default, a simple monitoring will give you 5 minute interval. Okay. I can call this web server 2. Configure security group, same security groups, review launch. So my web server 1 has a regular monitoring. My web server 2 has a detailed monitoring enabled. But if you're wondering, how can I enable detailed monitoring after that? Select your instance, go to monitoring here, and then CloudWatch metrics. It's a basic monitoring. Basic monitoring is part of your free tier. But when you click on enable detailed monitoring, if you run it for 5 minutes, then they'll charge you a little bit of extra. But again, as I told you, please do not worry about the prices because you will get refund from AWS. I'll make sure you get it. Okay. So enable detailed monitoring. Yes. So I wanted to show you how you can enable the detailed monitoring after you create the EC2 instance. I showed it to you. So both of them have detailed monitoring enabled now. And if you may be wondering what kind of metrics are there, see this one. You have your CPU utilization, you have your disk reads, you have discrete operations, disk writes. So you have your network in, network out, packets. So all of this one, CPU credit usage, credit balance. These are the statistics. These are the metrics that you can measure on. Yeah, good stuff. This is about the detailed monitoring, and we do not have any alarms at this point, right? So I have selected web server 1. By the way, you can go to CloudWatch and create an alarm, or in your within EC2 section, let's say I want to monitor this web server 1. Yeah. So go to monitoring here, click on create alarm. Okay, send a notification to, where do you want to send a notification? You can use CloudWatch alarms to be notified automatically whenever metric data reaches a level you define. So send a notification to, we only have one topic there, which is EC2 high CPU alert topic that we just created. You understand where I'm going now. Yeah. So you can actually take the action also. So what happens? My goal here is that if it goes above 80%, then send me a notification. Okay, take action. We'll talk about it. You can actually do the reboot instance or recover this instance. You can terminate this instance. You can do that one also. You can definitely do that. I'm not doing it for now. Okay, so whenever maximum CPU utilization, you can go with the average CPU utilization. I'm going with the maximum CPU utilization is greater than or equal to 80%. Okay, for at least one consecutive period of 5 minutes. Yeah, 5 minutes. So that means if it goes above 80% for 5 minutes, okay, then send a notification to this one, is what I'm saying here. Whenever maximum CPU utilization of 80% for at least one consecutive period of 5 minutes, then send an alarm to name of alarm. You just gave the name of alarm. EC2 CPU utilization about 80%. This is my name of alarm. That's all. Yeah. Create an alarm. I created an alarm. That is good. Now, what we'll do is you can do the same thing for web server 2, but at this point we created a web server 1. So now let's go to CloudWatch. Detail monitoring is enabled anyway. So now click on EC2. Yep. So to start with, it's insufficient data. It's in the process of collecting the data. Yeah. So let's go with the 1 hour and click on this maximize button, and then average 5 minutes, right? So average 1 second. So this is where we are now. Web server 1 is orange. So orange guy is here and blue guy is there. It's still coming up. So essentially what is my CPU utilization? At this point, it's 0. I'll take out this guy. I don't need web server 2. So now my CPU utilization at this point is about 0.18% to it's ranging between 0.18 and 0.32, meaning it's nothing, right? So what we'll do is let's log into that web server 1 and let's crank up the CPU. I'll show you how to do that. So let's log into web server 1 and crank up the CPU. Web server 1, connect. I use a browser-based SSH. I'm going to write a simple script. Okay, it's an inline script, in fact. So I'm going to write an infinite while loop, a simple script, like a while true. Yeah. I just want to echo something. I'm cranking up my CPU. I'm cranking up my CPU. Done. That's it. So it's going to echo this one infinitely. I'm cranking up my CPU. It's going to write to the disk continuously, infinitely, because I put a while true, right? While loop forever. So I wrote an infinite loop. That's all. That's all there to it. And let's give a couple of minutes. And what happens is this guy is getting cranked up now, and your CloudWatch will be watching it. So you can go take a look at it. It takes time, obviously. See, it said that it's in OK state. So at this point, your EC2 CPU utilization above 80%, that's the alarm. It's in OK state. So if CPU utilization is greater than or equal to 80 for 1 data points within 5 minutes, then you will get the alarm. But at this point, it's in OK state. Okay, that's fair. We are going to crank that up. We already cranked it up. So go ahead. Somebody has a question?
So why not put that on the /dev/null instead of coming on the terminal and throw it to the background, and then write a few more, couple of more such shell scripts?
Absolutely, you can do that. You can absolutely do that. This is just, I'm by no means don't count on just one way to do that. Yeah. So while writing to the disk, you can write to the null /dev null is your point, right? Absolutely. Absolutely. See, whatever it takes to crank up the CPU, that's all. It's almost at 50% CPU now. So
yeah. Then you don't need that.
It's whatever you need to do to crank up the CPU. This is just one way to do that. I'm no way saying this is the only way or anything. Yeah. So look at that guy. I don't need web server 2, and this is my web server 1, and it's coming up. See that it's gathering the metrics. It's gathering the metrics. It's going above. Oh, it's coming up. It's coming up. But of course, it's almost at 100% now already. It's at 100%, and it will stay there. It's going to stay there. See, this guy is somewhere here. See here, this guy is at 0. Whatever this percentage is, 0.16% of CPU, web server 2. But web server 1, that's where our script is running. That's at 100% already. And it's going to stay there. But it takes 5 minutes for our, it's already alarm notified. There you go. So it's all over. It's all over. This is an in alarm already.
So by throwing only one small job like that, it used the CPU 80%?
Yeah. It just, because ours is a T2 micro, it's a small guy, right?
Oh, okay. I see.
Makes sense? So this is alarms, and then notification. There you go, guys. Everyone, take a look at this. You are receiving this email because your Amazon CloudWatch alarm EC2 CPU utilization above 80% in the US East Ohio region has entered the alarm state because threshold crossed one data point was greater than or equal to the threshold. It's you put 100%. It reached 100% is greater than your threshold is 80%. Yep, makes sense. And it happened through SNS, simple notification service. So we created a simple notification service, SNS topic like this, and then subscribe through the email, and then CloudWatch. We created a CloudWatch alarm, and then said that, hey, keep watching my EC2 instance. If CPU goes above 80%, throw a message onto the topic, and then that's it. Make sense? Any questions?
One question. Yeah.
Absolutely.
So when I saw your email, right, it is showing a time period of 12:49, something like that.
That's a UTC time frame.
Oh, that is a UTC?
Yep.
It should be 5 hours, right? So, okay.
Whatever that one is. Yeah, it's 4 or 5 hours. I think 4 hours, right? 4 or 5 hours.
Okay, whatever it is.
See this one here? It's a UTC.
Oh, okay. Can we convert it into IST, I mean, like EST or something like that?
Can we configure this email? Is what you're saying?
Yeah.
I don't think so. I mean, then we have to write our own. Then you are not, rather than relying on Amazon's own, email notification. Then we have to write a Lambda, and then we have to send an email. I would not recommend that, but that's what it is.
Venkat, so here we have two services, right? One is SNS for the publishing queue thing, and the other one is the CloudWatch thing. So if we don't feed it to the SNS service, and then we just set up the CloudWatch, we're not feeding to SNS. So what will happen?
Well,
do we have to feed it to the SNS? Is it or?
What's your objective? Here, my objective is I want to get notified when CPU goes above 80%. If you do not need to get notified, then it just shows you as in alarm, but it just does not send a notification. That's all. So there are two different things. CloudWatch job is to keep watching these EC2 instances for it. Okay. But if it goes above it, by your threshold based on your business needs, you define your thresholds. If it goes above your threshold, send me notification is what you're saying.
Right.
Make sense?
Yeah. So it can be feed it to multiple subscribers, email and some other.
Absolutely. Absolutely. See this one here. That's the whole pub sub model, right? This is a pub. This is a sub in between topic. So the beauty is, the topic this guy will push it to multiple subscribers. So if you have your own piece of code here running somewhere in the cloud in the form of Lambda, this guy will call Lambda function. Or it can send a notification to a queue, which does trigger some other event or some other function, You can do that. You can do all of this. Does it make sense? It will send you send you an email to your on-call people. It will also send you an SMS to your on-call people, and also you can trigger a Lambda function, or if you write your own REST service to do something within your company dashboard or somewhere, it will do that. Fair?
Yeah. Yes, Venkat. Good.
Excellent. Somebody has a question?
Yeah, Satish. Yeah, I mean, like here we are using 3 services, right? So we have to pay for those 3 services.
Yes, of course.
Okay.
Yeah. So, and detail monitoring, as I told you, detail monitoring that doesn't fall under your free category. But I highly recommend you guys do this, please. Okay. Understand, appreciate what AWS has to offer. In general, these concepts have got nothing to do with AWS, guys. Okay, so these concepts will help you understand the systems at the architecture level. You may know at the application architecture level, or you may know at the code level. But now you're looking at systems from 10,000 feet view. Okay, how all these systems get linked up is the main idea there. Yeah.
Venkat, we got an alert, right? How can we find the root cause of this alert?
Oh, the root cause of the alert, unfortunately, your CloudWatch doesn't know the root cause. You probably have, not probably, 100%, you may have written some logs somewhere, right? And those go to those logs. So here in this case, Ram, I'm cranking up the CPU this way. So there is no clue anywhere, right? But but your application will not be like this, right? You may have written much better application in your EC2 instance that's deployed in EC2 instance, and you have a proper application logging, and those go into the log groups, look at your logs, and that's how you identify
all the memory leaks or anything related to the application is going to be logged here, or how can we know that?
Your application logs will be logged, yes. Your console.log, all of that will go into this one, or you can set up your separate log for just, to go somewhere else. Let's say you guys are using Splunk, right? So then you have to look at the Splunk logs, or someone is using Elk Stack. Somebody has to look at the Kibana dashboard to look at it.
So always logs are not going to give full information, right? So if you have a memory leak or something else in the application itself, how can we find those type of things? Is there any
that's your application problem, right? We are
now memory dumps or something, we can take it from here.
So see, let's talk about the segregation of responsibilities here, Ram. So what AWS is providing you is the infrastructure, right? But you are now talking about the application performance, APM, right?
Yeah.
So now when you talk about the application, then you have to look at your application architecture. So are my application logs enough to identify the root cause? Okay, let's say I know you're talking about a Java-based application, right? Yeah. So what you want to do, if there is a out of memory errors, then you want to dump your heap and thread. If you want to take your heap dump and thread dump, okay, and then analyze them separately, and then identify the root cause.
That's correct. But is there any way that we can take the heap dump from the servers? That's what.
Oh, absolutely. That's your EC2 instance, right? Like exactly like how you are taking your heap dumps in your organization. You can do it exactly, right? Because all it's doing is you have one Unix machine right now in your organization. You have a Linux machine in your organization. You have EC2 instance. This guy is at infrastructure as service. That's the flexibility, right?
So we have all those capitals inbuilt somewhere. Okay.
No. What I'm saying is that this is a Linux machine. This is your own Linux machine. Whatever you can do it in a Linux machine, you can do it here.
Okay, got it. Like a actual Linux machine, whatever we can do.
Absolutely.
We can do it here also. Okay.
I'm glad you asked that question. Let's spend a minute there. Okay. We talked about, remember on day one, we talked about infrastructure as a service, platform as a service, and software as a service. And this one, what we're talking about is infrastructure as a service. So you have your own Linux machine in the cloud, as if you have a Linux machine in your own organization. So if you have a Linux machine in your own organization, let's say you are running a Tomcat instance and you deployed your Java-based web application out there, and you have out of memory, and you want to take your thread dump and heap dump. How do you take it? Exact same thing here. Amazon is not in the picture.
Okay.
Does it make sense?
Yeah.
Because we're talking about infrastructure as a service. But if you go one level above and then talk about a platform as a service, that's where that's when we have to ask those platform providers that say, hey, if things go wrong, what kind of logging do we get? How can I get my thread dump? Then they might say that, we are providing you a platform. You do not need to worry about it. We have a separate mechanism for that. But here in this case, you have a machine for you, and you just do it like how you do it in your office. You send a stop signal or something when your JVM is running to take your thread and heap dumps, right? You do the exact same thing.
Yeah, I'm combining two things actually. I'm thinking about Dynatracer, this one. So that's why how we go there and alert system and we'll go to the root cause, right?
Yep.
So that's what I am thinking. How can we do that here? That's what, if I got it, what you're telling. Okay.
But did I make it clear?
Yeah.
Because that may be a question for a lot of people here on the call. So understand that. So this is your Linux machine. You do it however you want to do it. Yeah.
Yeah.
So, and by the way, all the logs, we'll look at it at some point later in the game. All the logs will go here. If you want to use CloudWatch logs, if you decide to use some other, log aggregators like Sumo Logic or, your Elk Stacks or Splunk, then it's a different story. So that's about it, guys. It's a small thing I wanted to share with you. You will understand why I'm sharing this. Okay, there is a more story to it. I'm slowly building, the Lego blocks to my end state. Okay, so I'm going to switch the gates again and talk about something. See this one here? You have an alarm state here. You are in alarm right now. Actually, go ahead.
So what would be the price for starting this?
What would be the price for starting what?
Starting this alarm.
Oh, what would be the price for alarm? Huh?
Yeah.
We'll have to check that. AWS, what's that? Sorry, CloudWatch detail monitoring. CloudWatch detail monitoring. It's a regular monitoring is pricing. So they might say metrics, basic monitoring is free, detail monitoring, metrics. First 10,000 metrics, 30 cents per month, it seems. Okay. This is again, per region also. There are some, if you go to some other region, price could be slightly different. If you go to, let's say, Sydney.
10,000 metrics means 10,000 like emails or any kind of subscriptions.
No, it's a metrics, right? Your metric, you are right. Your CPU utilization above 80% is one metric, right?
Okay. So whenever it is fired, that is one metric.
Can you say that again?
Whenever the alarm is fired, that's one metric. That would be. Let's say.
Hello.
No,
can't hear.
Oh, sorry. So whenever the alarm is picked up,
can't hear.
Oh.
Can we repeat that? Oh, no. Alarm is different. Metrics are actually your CPU utilization above 80% is a metric, right? See this one. Typically, read this statement here, guys. Typically, EC2 detail monitoring is charged at $2.10 per instance per month, almost 7 metrics per instance, and goes down to 14 cents per instance at the lowest price tier. Okay. So highest price to almost, it goes from 14 cents per month to $2.10 per instance per month, it seems. Okay.
Venkat,
I'm going to terminate. Yeah, go ahead.
can you please show that command that while to do?
Oh, absolutely. Absolutely. Let me say, I'll put that in the website also. And because I'm going to define, I'm going to design a homework for this one anyway.
Mm-hmm.
While true, this is a statement. And the next statement is, it's a simple shell script. I put it in a single line. That's all. Do statement. And then you can do anything here. You can do, you can write an additional statement. But all I just did was echo cranking up CPU, something like that. And then this statement is done. And you are writing a done statement. That's all.
Okay. Thank you.
No problem. And I sent you guys in the chat, and I'll put it in the Unix commands if it's not already there in my website. Yeah.
Okay. Another thing, that is the PPT that you were using yesterday.
Mm-hmm.
So where did you put that? If you put that on
this one, it's out there in my website. Mm-hmm. If not, I'll put it there. Okay. I'll show you where to do that. I'll take it offline. Yeah.
Okay. No
maybe it helps everyone. So go to AWS training videos. See here, there is a review for solution architects. I don't know if I put it up. So I made 3 long videos, each 2-hour videos. I presented it, to a forum of people. They're interested in. They said, "Hey, a bunch of people are preparing for AWS architect certification." They said, "We're all doing it. Can you help?" Then I helped them by giving this whole, detailed course into some 3 weekends, 2 hours each. So I'll put the presentation here. Okay.
Okay.
So. And go to my batch 2. You'll find somewhere here. I'll put that one. Not a big deal.
Okay.
Okay. So let's take. Let me stop here. Actually,